So Najib, let's look at the equation of a straight line, and we have two types of graphs. We have this graph, and this is a Cartesian plane, assuming that this is x-axis and this is y-axis. So if this is x-axis and this is y-axis, then we might have two types of graph. Number one is this type of graph, and number two is this graph. Maybe I'll draw it here. This is another graph. So a graph that has a straight line, irrespective of what point do they pass in the Cartesian plane, this is called a graph of a straight line. This is a graph of a straight line. But again, we might have what we call a curve. A curve is this one, which is not a straight line. A curve is this one, which is not a straight line. So the big question is, how do we get the gradient? We'll start by getting the gradient of a line, either a straight line gradient or a curve gradient. So for a curve gradient, we are going to get the gradient of a curve using the calculus. But for a straight line, yeah, we can use calculus or what we call a tangent, that is a straight line touching the curve. A straight line that touches the curve, that's what we call a tangent. So we can get the equation of a curve using a tangent by drawing this line that is touching the curve, which we call it the tangent. Or alternatively, we can use the calculus. But now let's come here. How do we get the equation of a straight line? That is what, and the gradient of a straight line. That's where we are going to start. So the gradient of a line, is what we need to understand. The gradient of a line is what we need to understand before we see how can we find the gradient of a line. So what is gradient? Gradient simply is understanding by how much has y changed and by how much has x changed, and what is the relationship between these two. So simply gradient is equals to change in y all over change in x. Change in y all over change in x. And what is the relationship between this change in y and the change in x? What is the relationship between change in y and change in x? Now, I want you to assume, still we are on gradients, I want you to assume, Najib, that we have maybe a point you have been given. We call it the ordinates. We have the ordinates like maybe A is 2, 4, and maybe B is 6, 8. Are we together? That is the coordinates we are always going to be given. Now always remember, these coordinates represent what? X-axis always. Okay? The reading on the x-axis. And this one represent what? Y-axis, right? So in case B, what is the value of x? 6, right? What is the value of y? 8. Now we are being told to plot this graph. Maybe it's a graph of a straight line, maybe. So we are being told to plot this graph. So x initially was what? Initially it was 2. Now it has changed to 6, right? Y was what? 4. It was changed to 8. So by how much has x increased? Okay.
4.
By how much has y increased? Okay. What is the relationship by the change of x and the change of y? Are you together? This brings us to the formula that gradient is equals to change in y all over change in x. Are you together? Change in y all over change in x. So what is the change in y?
4.
You will say 6 minus, change in y is 8 minus 4, right? Over 6 minus 2, right? X has changed from 2 to 6. There's an increase, right?
Yeah.
And then y also has changed from 4 to
8.
8. There's also an increase, right?
Yeah.
Now, what is the relationship between the change in x and then the change in y? Are you there? Now gradient is equals to 8 minus 4 is what?
4.
4. 6 minus 2 is what?
4.
4, right? So 4 divided by 4 is what? 1. So our gradient is equals to 1. That's what we call the gradient. Are you together? We can do another scenario. I hope this one has been understood.
Yeah.
Okay, let's do another scenario where we are going to be given a Cartesian plane. We are going to be given a Cartesian plane, and assume that this is the Cartesian plane, and then this is our y-axis. Okay, this is the origin, and this is the x-axis. Are you together? Now let's say our scale is 1, 2, 3, 4, 5, 6. Okay, and then we have 1, 2, 3, 4, 5, 6. Are you together? Now my first point, maybe point M, is 2, 6. Are you together? So point 2, the first figure here I said represent what?
X.
Reading on the x-axis, right? So we come and read here, the x-axis is what? 2, right? And then 6. 6 on the y-axis, we go up the line, up the line, up the line, up the line, up to
6.
maybe 6 here. Are you together? And then maybe our second reading is maybe, I can say maybe 5, and then y-axis might be 2. Okay, so we'll have 5 and then 2. Okay, so maybe that's our point, right? So we draw a straight line, and then maybe this is our straight line, right? Right together. Now the
Why-
reader,
Why don't you draw the straight line starting from the?
from this
Oh,
side, this way.
Yeah.
We just follow the flow of our current, okay, or our question. That's why we are having this stuff, right? But mostly we get right together. Or maybe I can just draw any. Let's assume any. It's not a must have this figure. We can just draw any. This is our straight line, okay? And then maybe point A is somewhere here. Right together? And point P is somewhere here. Right together? Now this is P. Give me the reading of P. Maybe you can say 2 is maybe here. So we might have 2, 2. That's our point, right? And then maybe points N will be
5.
maybe 4, and then 4, right? That's our point, right? Now the gradient is by how much has y increased, okay? And by how much has x increased. Are we together? That is now change in y. That is the y changed, right? From this point maybe to this point, right? And x changed from this point to this point, over change in x. Right together? This brings us to the formula that the gradient of a straight line is equals to change in y all over change in x. That's how we get the gradient of a line. Right together? Which line? A straight line. Right together? Remember I said for a curve, sometimes you might have a curve, not a straight line, but you might have a curve. So when you have a curve, then you draw what you call a tangent, a straight line. Right together? Or you can use also calculus. You can also use the application of the calculus to get the tangent. Are we okay? Yeah, so we can use calculus, but for now we are not dealing with a curve. Okay, we are dealing with a straight line. And as far as a straight line is concerned, the equation of us, I mean the gradient of a straight line is going to be given by change in y all over change in x. Are we together? Yeah. And one thing again, you can get Najib gradient of a line as even a negative number. You can get a positive number. Are we together?
So how are you gonna put it on the graph?
Now we are going to see. We want to see.
Negative.
We move step by step. For example, it's a graph. We are going to see. We move step by step. The first thing is we are going to see how do we get the gradient of a straight line. After getting the gradient, we are going to see the equation of a straight line. Okay? We are going to see the equation of a straight line. After seeing the equation of a straight line, we are going to see what we call the y-intercept. We are going to see what we call the x-intercept. We are going to see how do we put it on a graph. Putting on a graph is very simple. It's the simplest of all. But we need to have a build-up of this thing. So you can get the gradient, right?
Yeah.
Okay, let's try this one. Let's write down this question maybe, and we'll try it. Still we are under the gradient. We are under the gradient. Find the gradient of the straight line passing find the gradient of a straight line. Find the gradient of a straight line. Find the gradient of a straight line passing through the point. Find the gradient of a straight line passing through the point A, 3 minus 4 and point B, that will be 1 6. 1 6. Get the gradient, and remember you must show the formula. You must show the formula. Use the formula. Remember the formula, gradient is equals to? Yeah.
That's a negative right there, right?
Yeah, negative 3, negative 4, 1 6. Point A is
Negative 3.
3, positive, negative 4. Yeah, positive 3, negative 4. Point B is 1 6. Point B is 1 6. Get the gradient. Remember, it is the gradient of a straight line. The gradient is equals to negative 5, right? And negative 5.
I got positive 5.
Positive 5. Okay, let's do it together. We say that the gradient of line AB, gradient of AB is equals to change in y over change in x, right? How has y changed? Y has changed from minus 4 to 6, okay? Minus 4 to 6. So we'll have 6, that is gradient is equals to 6 minus 4. Right together? Over changing x, right? So x has changed from where? I gave y. Sorry. Yeah, it is y. Y is okay. X has changed from 3 to 1, right? That is, we have 1 minus 3. Right together? 6 minus 4 is 10, right? Are you getting there?
Yeah.
Yeah. Divide by 2. Minus 2 though, right? A negative divided by a positive will give us a negative. So our gradient will be a minus 5.
Yeah, I see that.
Understood? Let's try maybe the last one before we move to another one. Find the gradients of the following lines. Find the gradients. The gradients of the following words. Sorry. Following lines, right? Or following points. Okay, the first point is point A. That is P is minus 2, 3. 3 is a positive. The other point and Q is 1 9. Point B R is 3 minus 2. and S is a minus 1, 10. Get the two gradients. You can see?
Yeah.
Yeah.
It's shaking.
Find the gradient of the following points, that is P minus 2, 3, and Q 1, 9, R 3 minus 2, and S minus 1, 10, using the formula. Okay. Yes. Now, let's do it. The first one will be
-2.
yes. So we work it out. We say gradient is equals to change in y over change in x, right? Change in y is what? 9 minus 3, right? Change in x is 1 minus minus 2. So this will be 6 over 3, right? The gradient will be 2. Are we there? The gradient will be 2. The other one is this one. Gradient is equals to, again, change in y over change in x, right? Change in y. Y is 10. It was -2, it changed to 10, right? 10 minus minus 2, right? Over -1 minus minus 2. So 10 minus 2 is what? 12, right? 10 minus minus 2. I mean,
-3.